Intake air temperature sensor. The purpose and function of the intake air temperature sensor is to provide the engine computer with the temperature of the air entering the engine. The intake air temperature sensor information is used for fuel control, adding or subtracting fuel, and spark timing, depending on the temperature of incoming air. If the air temperature is cold, the electronic control unit will modify the amount of fuel delivery and add fuel. If the air temperature is hot, the electronic control unit will subtract the calculated amount of fuel. Spark timing is also changed, depending on the temperature of the air entering the engine. The timing is advanced if the temperature is cold and retarded from the base program timing if the temperature is hot. Cold air is denser, contains more oxygen, and therefore requires a richer mixture to achieve the proper air-fuel mixture. Hot air is less dense, contains less oxygen, and therefore requires less fuel to achieve the proper air-fuel mixture. The intake air temperature sensor can be located in one of the following locations. In the air cleaner housing, in the air duct between the air filter and the throttle body, built into the mass airflow or airflow sensor. The intake air temperature sensor is a low-authority sensor and is used by the computer to modify the amount of fuel and ignition timing as determined by the engine coolant temperature sensor. The electronic control unit uses the intake air temperature sensor as a backup if the engine coolant temperature sensor is determined to be inoperative. The intake air temperature sensor is a negative temperature coefficient thermistor that decreases in resistance as the temperature of the sensor increases. A negative temperature coefficient thermistor is a semiconductor whose resistance decreases as the temperature increases. In other words, the sensor becomes more electrically conductive as the temperature increases. Therefore, when a voltage is applied, typically 5 volts, the signal voltage is high when the sensor is cold because the sensor has a high resistance and little current flows through to the ground. However, when the temperature increases, the sensor becomes more electrically conductive and takes more of the 5 volts to the ground, resulting in a lower signal voltage as the sensor warms.